less to worry about in this session than the accessibility point. So is this working? Yes, it is. So I think we should say welcome to the Rmcat session. So Magnus will be the Jabber scriber and Brian will take notes. Thank you very much. And Mia will give out the stars. So let's get started. So this is the note well. We'll briefly pass through it, so we hope that you've seen it before. We'll first go to the chair slides and then we'll brush the agenda in the end. And you can find, this is the links to the material. The status of, we have quite a number of documents right now in the working group. We have a number of work group documents, and the first one, the requirement draft, is actually in the RFC editor queue, but right now it is waiting for some, because it has some normative references to some RTC web documents. So it's stuck there waiting for those to complete. And the other work group documents will actually go through the status of them in the chair slides, so I'll say more about that later. Then in terms of drafts, we have 2 congestion control candidates drafts that we will have presentations on today, and the plan is actually to call for adoption calls to see if the work group wants to adopt these documents today. We'll also have a presentation on the shared bottleneck detection, and also there we'll want to see if the group would be ready to adopt that work at this time and stage. We'll also have a presentation on the coupled congestion control and work with NADA. Then we have some more drafts in the group. We have one on cellular test cases and video traffic sources. We'll discuss, I don't know what happened there. It's not in my, okay, so we have some more drafts on test cases. We'll also discuss those in a little while. We have still a draft on forward error correction. We still that draft will remain as a draft right now in the working group. We'll see what happens with it, if the congestion control algorithms ends up using it or not. So it's definitely interesting and important work that we want to keep on as a draft, but we'll see what happens with it. And then we also have this new draft from Stefan Holmer about some extensions, and we'll discuss a little bit about that also here in the chair slides. In respect to the milestones, then we have a couple of milestones that we have done. Then right now we have, we hope that we will accomplish the milestone to adopt the congestion control candidates. We have already submitted requirements, but we have not submitted the evaluation criteria, and we had a milestone to submit that here at this IETF. We think actually that we will move that to after we have the evaluation results. It's because we think that the evaluations themselves may help update the evaluations draft. We'll say a little more about that later, but that's what we anticipate to do. And then we hope perhaps also that we'll have be able to adopt a working group addressing the milestone on the congestion control. And then of course the other milestones probably need to be put a bit further out in time. Then we move to a brief status on the evaluation test cases. I don't know, Sahid, could you quickly jump to the mic and tell us what the status is?
Jahid, yes. I think the new versions has some, is it like, sounds weird, but anyway, this round trip time fairness, I think there was some discussion in the internally, and this when we have been presenting results like this duration, so we have changed something, but those are really small changes. So what I really would like to focus on the issue list is like this missing Wi-Fi specific test cases. I mean, we authors tried to gather our head together and try to find out something, but it would be really nice if somebody else also can have a look at it. Let us know like what and how to do this to devise some Wi-Fi network specific test cases.
Yeah.
And of course we are waiting for, and we have used one traffic model that Varun has used in our draft, but there was some feedback from the group, like there might be some better models. But we are still waiting if there is better model. But I really would like to know like if that better model is needed or whatever we have it there is good enough.
Yeah, I think we think that test cases, trying to understand how the algorithms work compared to TCP flows or with concurrent TCP flows are very important.
Varun Singh. So just a pointer that the traffic models have actually moved now to the other draft, and because they were in the appendix before. So.
Yeah. We'll have
We still point to that one, so in this draft.
So there's one issue here about the wireless test cases, and we'll actually jump to that on the next slide. And then there's an issue in respect to test cases for TCP fairness. Is that what you're saying?
Yes.
So we need to speak to, originally Randall was supposed to provide some information on that. So we need to see if Randall can do that, or we need to see if we can find information from somewhere else.
I think it has been 3 IETF meetings that we have been waiting for Randall to provide. So I really like to know if whatever we're using right now is good enough or not. Do we really need a new one, better one? I think Varun has shown some results with that one. We have tried it out. It kind of simulates the short-term behavior. It's only a matter of look how many of them and what is the spacing between them or start and stop, all these things.
Yeah,
so
I think we'll take.
So basically what you're asking for is reviews from other people who might have more experience or might have experience on TCP evaluation. We can find people.
Yeah. Thank you.
So we'll do that. Jumping to the issue that you mentioned about the wireless test cases, then right now what we have is we have a working group draft on the evaluation test cases, and then we have 2 other drafts, one that specifies the cellular test, some additional cellular test cases, and we also have another draft that specifies the traffic sources or a model for how to...
Synthetic video sources.
Yes. And I think that, our view on this is that we actually need to follow up on all 3. We cannot really make reliable tests without having a good model for the video traffic. And also, we also need to perform tests in the cellular environment. So we think that we should move on all these 3 works. Yes, Magnus?
Yes, Randall Jessup, he says, I will talk to Patrick McManus if he knows anything, but I don't have contacts in the academic community that typically has models available.
This was about the TCP issue.
Yeah, short-lived TCP model, yes.
I think it's actually on the previous deck.
Yes, exactly. Yeah. Okay. Thank you. So we'll speak to Randall and see if we can find some reviews on that. But on these, generally on the evaluation test cases, we think that we need to have the content of all these drafts in and work with that in the working group. We still think that we could end up producing only one RFC in the end. Of course, if we get wiser along the way and say, well, this is that they need to be separate, we can always take that discussion. But our starting point is that we produce one RFC. So what we want to understand now is, first of all, if people agree with that we need to proceed with all the content. And secondly, we need to understand if it's important to adopt them individually, or if you think we can just merge the 2 individual drafts, the content of the 2 individual drafts, into the test cases document. So do you have any feedback on that?
Jahid again. Merging this Rmcat eval test cat and eval cellular test cases into one right now, it could be done. I think it's okay, and I think you were saying also like on the way forward, if we think like it need to be separated, we can separate. I think that's fine. But I think I'm not sure about these video traffic sources because we're still having listing different models. We have not come up with a single model that we can refer to. So I think that need to be proceeded as an individual and later on perhaps merged with the test case as an appendix or something else, I don't know. But the test case has the model. I think if there is a traffic model, that need to be go to this eval criteria actually, not the test case.
I actually say, are people using the wireless test cases? I know that you're using it, but I would like to get more feedback from the group of if those are ready to be merged in, if those test cases are helpful, if these are the right test cases. If you're the only one working on this worries me a little bit.
Yeah.
Varun Singh. I think one of the challenges with the second one is, I think it's been pointed out before with the cellular test cases, that not all of us have access to a simulator. And
But you have.
I have a different one, but it doesn't model like perhaps 70% of what is in that draft. And
but that's what need to be in your feedback, that need to be told, like, okay, yeah, this doesn't work. We cannot model it. How do you do that?
I think there are too many things, since you also model the radio network below, which is, I would have to spend many man-months to do this, and I don't think I have the energy to actually, or be even the pointers to implement such a system.
So do you think it's possible to simplify those test cases so you could easily implement them and they would still be useful?
I think the test cases are very useful. I don't know if the level and granularity that's currently in the draft can be implemented by me. Perhaps someone else can do it. Maybe
so do you think it would be a good thing to have like point to something that where you can actually implement such thing? So you want that from us also? Like you have this Luna in NS3 that there you can actually simulate, and that's publicly available wireless. I think in Toronto University they're using some publicly available LTE simulator where you can actually download it and use it. I don't know which one you're using, but there is a possibility. If you want a pointer to that one, perhaps I can work on that one.
Varun Singh again. I think I would appreciate at least feedback from those people who are using those third-party simulators to say that if they are able to simulate these test cases in those environments. I think that would be the minimum that would be expected.
So that doesn't constrain what we do in the working group, but I think to have a useful document here, it would be actually really useful to have something in NS3, so people can use it not only for Rmcat evaluation, but other cases as well. And that should be the idea, that we actually produce documents who people might read and use, right?
But the thing is, like, I cannot promise to contribute on NS3 from looking at what we have in our back of my hand. But of course, I can look around and see like if people are using what kind of simulator, and perhaps something that I can point to, of course. But I mean, Varun said like he cannot really implement all the details there was. But if you put up a mail saying like what are the things you cannot really simulate, then perhaps we can think about it.
Okay,
that would be good feedback.
Then I think we should encourage that we have a discussion on this on the list, and with the aim to perhaps have a good view on this, and possibly could adopt at the next working group, depending on the outcome, of course. But I mean, we should encourage that we have a discussion on this and try to resolve it.
So I think that's the point where if we all agree we need those wireless test cases, we can just adopt it right now and keep working on it.
But I think that was what I wanted to know. Like, if there anybody don't think like wireless test cases is not needed, for Rmcat I think it's a must. We're talking about point-to-point communication, and look at your home and your use case of like how do you use your phones and laptops at home. So wireless use case I think is really important for Rmcat to be successful.
So that's the point where Michael might say something.
Thank you. Michael Romalo, Cisco Systems. Yeah, it has to do with the charter, and also has to do with what it is that we're testing here. At Transport, we normally ignore the link layer stuff, but and historically, with loss being the brutal hammer signal that it is, that we're able to back off. But we're doing delay stuff, and the link layer characteristics are pretty important. A lot of our simulations, virtually all of them, are based on wireless shared queues. wireless queues of various forms, be they Wi-Fi or cellular or 4G or 3G or whatever, have different criteria, generally per user or per endpoint queues, and then there's this other entity, be it a wireless access controller or a service provider, a base station scheduler that's making other trade-offs for how much bandwidth you should get relative to its favorite customers that are also using that base station. So that problem is very hard. I also agree that it's an incredibly important use case, right? My problem is how do we codify that in the charter and then in also the work we do, given that the response to some of these things might be diametrically opposed to what you do in shared queues versus per user queues. So we're opening up a can of worms. It's a useful can of worms in that it's reality, right? We're trying to develop this stuff for wireless. So at a minimum, I think it needs more than just mailing list discussion. It may in fact need incorporation into the charter, and I'm pretty open about that. I don't have a particular position except to maybe reflect it back to the chairs to find out, you know, what do you feel that we should do. If it ends up being in the charter, then we have a harder problem of characterizing it, and that's actually what I'm doing within Cisco right now, and it's not an easy one. So I'm going to first toss it back to the chairs to find out, do you think that we need to say something in the charter about these important link layer kind of issues that impact what it is that our protocol needs to do or not? I don't know. So I'm sorry for not giving you a solution, but rather just posing yet another problem.
So regarding our charter, it's not excluded. I mean, it says we should provide evaluation criteria, and it's a decision of the group if we want to include cellular networks in those evaluation criteria. So I don't think, I mean, like rechartering just to basically add half a sentence, I don't think that makes sense. It's included, we can work on it, and we have to make a decision as a group. But the problem is, like, the group of people who actually at the moment try to decide something is very small. So
Xiaoqing, I have a comment/suggestion regarding actually the previous issue, but related to the cellular one. Given that wireless is reality pretty much, you know, for our devices now, but probably Wi-Fi is more prevalent for the use of Rmcat than cellular. So I would suggest that at least we come up with something based on Wi-Fi first before. It's a separate issue whether we want to combine everything into one document or sort of have standalone drafts for now. But as Zashi mentioned, we do want to have some Wi-Fi test cases. And personally, I don't think, you know, like a few paragraphs would suffice. So it might be easier to just come up with another draft similar to the cellular draft. And then as we move on, as we understand better the wireless, sort of have more confidence on the characterizations of the wireless test cases, decide whether to merge them or, you know, leave them alone.
let me ask you a question. Did you implement any wireless test cases for your evaluation so far?
For the simulations, no. So for instance, the cellular one, we found it, we didn't really know how to work with them. We actually asked Eric, asked people, and it's pretty hard to, sort of merge. So there's also the practical issue for algorithm solution evaluators being able to use these cases, because for wired, it's fairly easy to, sort of set up the test case as specified, but for cellular/Wi-Fi, we also need to keep that in mind to make it doable for evaluators. That's a second comment, yeah.
Okay, but then I've heard like 2 times that people are not able to actually implement the draft, which, is a problem, right? So we should come, I mean, if we have something which can be implemented by more than one person, that would definitely be more useful.
Jahed, yeah, I heard that, but I would like to know, like, why they can't do it. That's basically my question is. But I actually, lots of places I disagree with Xiaoxing, like is Wi-Fi and cellular, you can actually prioritize between them two. I don't agree with that. You can really prioritize between Wi-Fi and cellular. But anyway, yeah, if you have comments like why you cannot really implement it, I can really handle it. But I think it's pretty agreed in so far what I'm hearing. Like these are really useful test cases, and Rmcat should really care about it and work with it.
So do you think we'd be able to simplify the cellular model
of
the network, so that
I mean,
could be helpful, right?
I mean, if you hear what Michael was saying, like this, the schedulers and everything, we try to go on that detail so that we understand. We don't say like, okay, just pick one scheduler. We say like proportional fair scheduler for this, and then we can agree, disagree, like whether there should be delay scheduler or proportional fair scheduler. But it need to be specified for what's like relevant to Rmcat. So those discussion I really wanted to have, and see like how we can simplify these things so that people can really implement it. But I need to know like what I need to simplify, right? So that's what the main intention of that graph is. That graph is like go in details and then see like what is the most important information that people want to simulate and people want to see effect of.
Okay, let's hear the other people on the queue.
Geert van der Rauwrak, Qualcomm. I think Wi-Fi and cellular, the boundaries are fading, that there are handoffs considered between the two. So it's hard to, even for the user to know what network he is if he doesn't look at the configuration. Regarding testing, maybe an option is to have like real-world traces, measure them on a real network, and then feed them into a simulator. I'm not sure. In the company, we have, of course, all the equipment, but for simulation, maybe traces is an option.
Can I say something? Oh, okay. Can I say something
can
to
you
that?
just cue?
Yeah.
Well, yeah, let's Magnus Westlund, first channeling Randall Jessup. Strongly agree we need to test and work well in Wi-Fi. And then he has a later comment also about evaluate criteria 4.5 says the congestion control algorithm should be assessed in heterogeneous environments containing both wired and wireless paths. I also have Stefan Holmér. I agree that Wi-Fi is very important as well. Could it be possible to simplify simulations of both Wi-Fi and mobile networks by instead recording packet traces?
Yes, still Michael Romalo, Cisco Systems. It's very important. In the ideal world, we do some wonderful characterization of every possible Wi-Fi access characteristic and also every possible cellular 4G characteristic, and develop, the magic algorithm that does well in all of them. Problem is, this is a very tough problem. We too also have implementations. We just don't want a sample of what Ericsson's does, but we have one, but we don't know how representative it is with the rest of the world. It is a very difficult problem. Also, if you look some of the work, and I know that you know some of this work because you've talked to the guy at MIT whose name I'm having a moment on, Keith Weinstein, yes. And some of the characteristics are actually a function of how hard you pound the network in your own user queue. So it's really kind of hard even to data drive or drive characteristics off of data traces, because the response of the network is actually a function of what you're doing to the network at a given point in time. So it's not a stationary process. So why am I doing all this? I think it's useful, and all this stuff ends up being basically phase noise that is unrelated to your own action. Sometimes it is, sometimes it isn't. I'm just saying that I think it's useful. I think it's useful to have some characterization, but know that this is a moving target, and it's a function of things well beyond what we're doing here, because this link layer is just so wacky. Sorry for not having better solutions, but internally that's what I'm doing. I'm characterizing these networks and then subjecting our algorithms.
We need to cut a little short, yeah.
Quick comments in response to earlier comment. For Zahid, in terms of implementation, yes, we can implement everything, but we, as evaluators, we really want to have something that we can work on top of. Just like, how NS2, NS3 provide ready modulars. We don't really want to spend, a long time implementing something specified. If there's already a tool, that's going to be great. Second, for the comment from Qualcomm, we agree that Wi-Fi, sort of in terms of networks, Wi-Fi cellular are merging, but as I understand it, their sort of transport characteristics may still be different, so it might still make sense to characterize them differently. And real-world traces are always welcome, for sure.
Please keep it short.
Yeah. I have one one idea about getting this real world trace, because from a company point of view, my company is not, I don't think we'll be able to provide any trace. I'm talking about Ericsson, I don't know about Qualcomm, but I think one thing we could do actually, talk to, send a liaison to 3GPP, and then basically ask them how to do this thing, the trace part, and they perhaps will provide the representation that's covered the wider area by getting a trace file or whatever you want from them to actually try out cellular test cases. But I also would like to say, like, the simulator or emulation based on trace files has its downside, what Michael was saying. So think about that also.
Okay. We want to cut the line now.
So I can speak?
Yeah.
Varun Singh. Yeah, so I'll just re-echo what Gert said, that we need to do both, as in we cannot just do Wi-Fi and not do cellular, so we should do both wireless cases, that is cellular. I would also re-echo what Stefan and others have said, that perhaps using a trace is easier. We've already gone down that route with the traffic source, that we model the traffic source and we don't actually use real video in the initial cases. So we could go down that path even with the cellular case and just simplify the problem and use traces. How we get the traces, of course, another problem, and I guess there were several solutions already mentioned here, so we should just pick one of those.
Magnus Westlund, first channeling Randall Jessup. We don't need perfection. Agree a simplified model is good enough until we do in the wild tests. And Stefan Holmer wants to say, the nice thing with traces is that we can just go out and record them ourselves. Smiley. Happy smiley.
So I got the feeling that people want those test cases. They think it's important. So basically the question would be, is this document we have right now, and that's the only one we have on wireless test cases, right? Is this a good starting point? So we want to adopt this as a working group document where the next work item would basically be try to simplify it. Yeah, I basically, should we do them, right?
I think that the aim is not only the cellular, the aim is for it to be wireless cases.
Yeah, wireless and cellular. Yeah. Actually, who read one of the versions? Yeah, so there's some, okay. So actually, let's do HUM. Who thinks this is a good starting point and could be adopted as a working group document? HUM, please. Who thinks this is not a good starting point and should therefore not be adopted as a working group document? Please HUM. Okay, we will confirm this on the list.
So we'll quickly move on.
Just have a question. If we're doing the cellular case, the point is, do we keep the Wi-Fi in the other draft and move the Wi-Fi in here as well, and put the whole thing as a wireless eval test case, and or why should the...
Actually, I think that doesn't really matter because the goal is to merge those documents.
Okay.
So we should just keep it in a way that we can handle them. Randall supports adopting the document as well.
I think we could probably leave it up and see whether if we want to split the wireless ones in the existing one or in the new one. I mean, that would depend on how it's best to work on this.
Very quickly on the video traffic, so like we as a chair think this is a useful document, and to actually make the evaluation useful, we need a video model. Any opinions on this right now, or do we have to wait? Like, what are the open issues? Is this something we could merge soon? Is this something the working group is interested in? Just very quickly.
Yeah, I'm one of the author of this draft, and I think we need another revision to really work around if we are going to merge the models, or there will be two separate models or something like that. At least one more iteration.
Okay.
Varun Singh, we've implemented the second model. We would like to see this thing move forward.
So this model in this document?
The second model in this
okay.
model and in that document. There are some minor changes, but I think we've already relayed that to Zahid. I don't know if you're going to pursue both, so it would be nice to know if they're going to merge it so that we can make the appropriate changes.
Xiaoqing, so basically, for the statistical model, we need to provide some validations before people can really go ahead and use it or believe it or discard it. For the trace-based one, we believe it's pretty safe. We just need to accompany that with maybe open source sharing of code plus traces.
So would it be an option to merge the trace-based model into the test case document right now?
It doesn't really matter, right? Yeah, we don't
So
really...
yeah, no, I mean, like if we can merge it now, we don't have to adopt it separately. That's the point.
Oh, okay.
Yeah.
I'm fine with that.
Okay, perfect.
The val test or the val criteria? Because I think we kept all the other models in the val criteria model. So I prefer that all the models stay in one place.
I mean, yes, I'm not. I mean, if the models are in the test, in the evaluation criteria, and then they should match over there. Yeah.
Okay.
Okay. I mean, actually, I should review all of the documents right now again and figure out where what belongs. Okay, let's do that.
Quick comment, right now the draft is pretty long by itself, so it might, even if you merge it, it would show up as...
So, yeah, I mean, like what we said is like our goal is to have, in this case, basically two drafts, the evaluation criteria and the test cases at the end, which go to an RFC and no other documents, which will be long documents, but it's also easier to proceed only two documents than like 4 or 5 or whatever. Except you think there is a value in having this as a separate document because other people would use it in a different context, and so it should be standalone. But I don't think that's the case, right? Okay, I'm seeing nodding. Okay. Okay, and now Colin is coming to the mic.
Hi, Colin Perkins. I support the video traffic modeling stuff. To me, it struck me as being somewhat different to the rest and something that should perhaps be separate. And yeah, that's sort of separable, but I don't suppose it matters that much.
I mean, my view is that this is mainly work we are doing actually to do the evaluation within this group. So we have to know where the right stuff is described, and it's just easier to proceed less documents. I don't think it matters that much.
Sure.
Yeah, okay.
Can we have a 2-sentence readback of the minutes of what just happened? Because it's not at all clear to me that everyone who was using the word "it" to refer to a document was referring to the same document. So I'd like the chairs to read back what they think just happened to make sure everybody has the same understanding, because maybe I just haven't had enough coffee, but I lost complete track of what just happened here.
Okay, so we agreed that it's useful to adapt the cellular document and merge the wireless test cases into, oh no, actually we decided, okay, I start over again. The goal is to have two documents at the end, the evaluation criteria and a test case document. Nevertheless, we decided to adopt the cellular network, the cellular test cases, because we want to proceed this document. We think it's important to have those test cases, and the idea is to simplify these test cases before we can merge anything. For the video traffic source document, we decided to not adopt this now, but potentially merge part of the content into the evaluation criteria. Yes.
And then very quickly, we have a slide on the evaluation criteria. I don't know if we need to say any more details about it. Basically, it has been updated. The traffic models moved from the test case draft to the evaluation case draft. And what we've said is that we want to keep this document alive until we have the evaluations of the real candidates. Then one more issue that has come up during on the list. One more issue that we have is that we have this document on the application and condition control interactions. And what we have discussed that some among the authors of the documents, and we have made a proposal that we'll actually take the existing work group document and we'll terminate that. What we want to do is that we want to split it into 3 more focused documents. One that will describe the condition control application interactions, which could then, for example, be provided to the W3C working group, solicit for input, and Varun has volunteered to be the editor of that one. We would also have one very focused document on the congestion control codex interactions, and Mo would be driving that document. And then we think that, I mean, a lot of the information that is in the present draft is actually very useful and will be useful for the work that is being undertaken in this working group. So we think that we should make a framework document that we can at least use that will describe the internal building blocks and the interactions in between these internal building blocks. It will be, at least for internal discussions in the working group, we'll see whether it will be relevant to publish at some point in time. And we think that the present drivers of the congestion control mechanisms will drive this document. So that would be Sahid and Xiujing. And we still want to emphasize that even if we have this framework document, we do not want the experimental RFCs for the congestion control algorithms to refer to this framework document. We want those documents still to be standalone document describing the framework that the individual congestion control is established. I mean, at least for now. Then something more, I don't know if there's any reaction to this. Could we, if anybody is opposed to this, please go to the mic.
So we had a small meeting with the authors yesterday, so that's the outcome. So people who haven't been at the meeting are hopefully not too surprised, but that's the solution we came up with, and that's, I think, the way, one way forward.
And please go to the mic if you don't agree with this.
Sit down.
Michael Ramal, I agree with this, but I do have a procedural question about it. Okay, so it's not a disagreement. This is already a working group document, the one that exists now. So that by definition, are all three working group going to be working group drafts, or okay? So they all three have to go through the process of being. So this one basically is struck as a working group item, and then three. Thank you.
Yes.
Okay, we should move quickly, but I don't know. We'll try to make this as quickly as possible. So there's been emails on the list, and there's been a discussion about whether we need an architecture or not, and also there's been discussions about the feedback extensions that we perhaps will end up defining. So I think that what we think as a chairs is that we have an existing work group document on what extensions that may be required in order to provide the feedback from receiver to sender. And I mean, this document right now says that no extensions will not be needed, but that may not be where we end. So this document will have to evolve as we get wiser in the working group, and it will have to take into account whatever new insight. And one example of new insight is the draft from Stefan. Not saying that Stefan's idea should be merged into the working group document at this point in stage, but we'll just have to see what happens. And our idea is that we'll have to see what crystallizes in terms of feedback, extensions, and architecture as the congestion control algorithms move ahead. That we don't want at this time in states to start a general discussions on architecture. Rather, we'll see what happens very concretely, and then when we have the solutions, we will have perhaps to revisit the discussions about the architecture and see what was the extensions.
Mozanetti, I think this is going to be an important area to think about because it actually is spanning areas now. There are other reasons in RAI where we may end up having some act-like mechanisms for resilience and for being able to switch media in some conference scenarios. So whether or not there may be a hard requirement for some extensions for congestion control is not the only question. It's also potentially can we use techniques like this because they may be required anyway for some other reasons in RAI.
Varun Singh. So I think the idea of the HOMA draft is good, but I don't think this is the right group to actually adopt it or even work on it or even merge it with the RDPCC feedback draft.
No, the idea was not to merge it. It's more that we have a document right now. Well, the idea, this working group is chartered to specify if we need extensions. Then another working group would have to standardize the extensions. Right. But right now we have a working group document that says that we don't need extensions. So if we end up with a solution where we need extensions, then the working group draft would have to say that. So I'm not saying that I agree with your statement, so this was not to say, it's more that the architecture that such a feedback mechanism represents needs to be described in the draft.
I suppose the other way is just to go to the AVT star whatever X or group and define what you want, and then come back here and say this is the feedback message that we've defined and we think is useful. And
say the draft currently describes an RTP extension. We are not chartered to specify this. That's very clear. Like everybody is free to go to a different working group and bring that draft there, right? Yeah. But what I would like to do is before we actually bring something to a different working group is to figure out what we really need for maybe more than one candidate, and then go to the working group and actually do something useful, not the first thing we get on our mind.
Cool.
And one charter item or milestone we have is to specify requirements for such an extension. So that's a document we should write in this working group, and then bring it to RWT extensions or whatever, and say, okay, please get us the right extension we need.
Okay, thank you for the explanation.
And now I really want to hear the feedback from Colin.
Hi, Colin Perkins. I think your characterization of the CC feedback draft is not how I interpreted that draft evolving. There are, I think, two types of extensions you can make to RTP. There are extensions which fit within the existing framework, and there are extensions that change the RTP framework. I interpret the CC feedback draft as doing some analysis to demonstrate that the existing framework for providing feedback is capable of providing timely feedback, so that we require no extensions to the existing framework. As I recall, that draft says absolutely nothing about the type of feedback, and says nothing about whether we will need new types of feedback message within that existing framework. I would expect each of the congestion control algorithms would make proposals for extensions to RTP in terms of new feedback messages. I think that's completely independent of the CC feedback draft, which is discussing whether RTP itself needs to change, rather than whether we need to define new feedback mechanisms within the existing RTP framework.
Okay, thank you for clarifying. Do you think we could extend this document to actually address both of those points? Or
no.
No, okay.
I very much think that they're entirely separable points. One is discussing whether the framework needs to change. One is defining new things within the existing framework.
Yeah, but I mean, like, we're not defining those changes anyway. So all we should do here is define requirements to those.
I think the congestion control algorithm drafts will even need to specify how they use the existing RTP feedback mechanisms, or will have to define new mechanisms. And I think this group will have to do that.
So we have a milestone which says determine if extensions to RTP or RTTCP are needed, and provide requirements for such extensions. So it's really just about describing the requirements for these extensions, and I think that could fit into this document.
So I don't think you're... So I think for the purpose of this document, I do not believe there will be any such extensions. And certainly how I interpreted that milestone was changes to RTP itself, rather than new feedback messages to be defined within the existing RTP framework.
So you say we don't need to define any requirements for any new extensions of feedback messages?
I do not believe feedback messages are extensions to RTP in the way that you are suggesting. That they're new feedback messages, they're not changes or extensions to the RTP protocol.
Okay. Okay.
So I think I would expect the congestion control drafts would potentially define new feedback messages. I think this draft is talking about potential changes to the protocol framework itself.
Okay.
Michael Romalo, Cisco Systems. I was going to say just agree with number 2 and sit down until Colin elaborated. Colin, you said that either things that you need in RTP to accommodate this, things that break the existing RTP model. And then there's another one that's mostly orthogonal to anything that's an RTP, and perhaps Homer's draft goes towards that end. I think you're right in that if somebody decided to put some information in a message and feedback independent of the RTP framework, that they're free to do that both here and in Transport Working Group and a lot of other working groups, as you say. So I think that we should see what crystallizes, because at first there's an information theoretic what it is that we want to do with media here. And then there are other things like in this draft that actually can bundle and aggregate stuff that's going on maybe outside of media flows, put them into a congestion control context that's useful, and actually throttle on the aggregate. So I would just petition for number 2 and not assume necessarily that we've broken RTP or that we're 100% using it or that we've excluded the possibility of other people using a congestion control framework that maybe just considers us as a subset, you know, the media. So I don't know. I just vote for the second bullet.
Just to clarify, I mean, it's not that these are not alternatives. I mean, the second, I mean, they are all consistent. In the sense that, I mean, we will in the end have to look at what we've ended up with and whether, for example, if we have multiple mechanisms, if they are interoperable or not, depending on how they work.
Jahid, what I think is like, even if we put up some requirements on like requirements on new RTCP feedback messages, we need to really say like why we actually need new RTCP feedback messages, like why we can't use the existing like Timber or something. Or there was another proposal from Google was Rem, and I don't think like they have pursued it or not. But that's basically, I think, what's really need. Why the existing feedback message is not capable of what Rmcat we're going to do. And to do that, actually we have to understand like how frequently and what are the information important for NADA, Scream, or whatever else we're going to have. So I actually agree with you, kind of like we have to wait on that one before we actually put up some requirements. But we can start with something like why existing. I mean, we like Scream has its own feedback message. So we need to say like why it's not going to work.
So do we have to say this in this group, or is it something if you write a document which just specifies a new feedback message and you bring it to general working group in this document?
I think so.
Okay.
Magnus Westland, now speaking for myself. I am of the opinion that the congestion control algorithms themselves should specify what information they need and kind of outline what the requirements are. And that, I think, is sufficient in the first stage of testing, and when you want to go forward to actually having something which you can reliably test in the wild, so to say, and you actually want to be able to detect it and handle it in a more global environment. That's when you take such a proposal to AVTX or AVT Core to actually realize it into an experimental or standards track document for an extension. So.
Colin Perkins, just to follow up from, I guess, Michael Romello's comment. I mean, I think the second bullet point is important. You know, my belief is that we won't need to change, you know, RTP itself, and change the timing rules and the feedback rules, for example. But it's possible that we'll find out we do need to make such changes. So obviously we should wait and see how these things develop before we really make that decision. I do think it's very likely we'll need to define new feedback messages within the existing framework. But again, obviously we need to look at what the algorithms need, what feedback messages we already have, and whether they match up, and if not, what extensions are needed.
Yeah. I think one thing is that we need to wait and see what we end up with in terms of feedback messages. And then there's actually another aspect, and that is if they are too different from the different algorithms, we need to understand if the different algorithms can be interoperable or not.
And also what's needed in terms of timing of feedback.
So you just say the current working group document should just stay open until we got further in the process?
Yeah, I think so.
Okay.
I mean, the current document, I think, is describing the timing of feedback and mechanisms along those lines. I would suggest that actual requirements for feedback messages should go into the algorithm drafts,
Okay.
but if you want to have a separate document for that, I guess that could also make sense.
No, that's the second opinion we heard, and does not actually make sense, I think.
Geert van der Aura. Just from our point of view in cellular and 3GPP activities, I think it is feasible to build a congestion control that works with what's currently there, like timber messages, etc. But otherwise, if somebody else has a better algorithm and needs special feedback, that is fine. That's a good research direction. Just to clear that up.
Jahid, I don't think 3GPP has an algorithm.
I'm
It
sorry.
only, it has? Yeah, so it only says like this,
I think we
we
want to
use
cut that-
timber.
I think we want to cut this discussion now. So finally, I mean, we've spent a lot of time on this, but it was also some important issues. So we have an agenda here, and we will not meet the time as it is. So we'll have to take some minutes away from each presentation. But the next presentation we have up is the shared bottleneck detection.
Good morning. This is an update on the shared bottleneck detection draft that I'm doing together with Simona and Michael. Okay, just an overview. The mechanism is based on using summary statistics. And why we use summary statistics? Firstly, we want to be able to limit the feedback from the receivers to the senders. It's a way of dealing with the noise in the system and also helps us deal with differing path lags. Okay. Thank you. Okay, the statistics we use the statistics we use are a measure of delay variance, a measure of delay skewness, a measure of how the delays oscillate, and a measure of packet loss as a supplementary measure. Now, an overview of the work so far. We've had a look at the mechanism through simulation experiments. As was commented on previous occasions, quite difficult ones to test it under different circumstances, and also a real network tests over the internet and 3G mobile using NorNet. There's one publication at the moment that was in LCN last year. Now, the key changes in this draft since last time, the terminology has been updated a bit to make it easier to read. And there's two new sections. One section on reducing the noise in statistical estimators. What I did is I went through a whole lot of tests and looking for odd sort of little outliers here and there and tried to explain them, and in this case found that in certain circumstances there was some noise in the estimators that could be removed. And that's what that's about. And then a section on how you would go about decreasing decision lag. Now, the first one, removing noise in the frequency estimator. The frequency estimator, or the oscillation estimator, uses a long-term mean delay and then looks at how many significant crossings the mean in over time t crosses that mean, and counts them and gives a normalized value for that. But if there's no congestion, what happens when you do that is you end up with a whole lot of noise. Then when you do get congestion on your path and you want to group flows, then you've got to wait till this noise clocks out. So this enhancement improves that by removing that noise so it doesn't exist. And the way we do that is for every T interval where we calculate the packet delay variation. If there's no congestion, we signify that with something like a not a number, or it could be a negative number, since we don't, it's only positive. And then when we calculate our estimate of variance over the M samples, then it's a sum of only the valid samples that we took, and that means we don't get that noise. Now another thing I found in certain circumstances where you have a congestion control working and one of the flows dramatically decreases its send rate for a short time and then increases it again, you can end up in a bias in the skew estimate from that period where you had a very low rate. And if it's for a short time, then that can influence and make the grouping a bit more difficult. So the way to avoid that is, rather than just do a simple average of the skew estimate, is to keep a base value, which is the sum of the one-way delays less than the mean minus the sum of the one-way delays greater than the mean, and then use that base value at the end to calculate your skew estimate. So you remove that bias that you had with small sample sizes over a T period. Adjusting for clock drift, now generally over the timescales we're looking at, it's not a big issue. But recognising that there could be circumstances where this is an issue with certain endpoints. So, and if it is, it could affect and influence the estimators that we have and make it difficult to group. Now, possible approaches, you can shorten the time that you're looking at and averaging over. But of course, you get poorer estimates if you do it that way. The standard way of looking at this is looking at a long series of minimum one-way delays over different intervals and using that to estimate the clock drift and adjust accordingly. We don't keep that many samples at the moment, and we don't actually keep a minimum one-way delay. You can't use everyone because you've got to bear in mind there can be standing queues and so on, and so selectively choose your minimum one-way delays. So at the moment we don't do that. It could be done, and I'll look to see whether there's any advantages in doing that. The simple approach proposed that I've tested at the moment is to use the mean one-way delays to look at it. Now yes, that's not going to be as accurate, but it doesn't have to be as accurate, it just has to give us the right estimators to do the grouping. And I believe that it actually does that. And what we do is we take our N samples and we divide them in two halves, an older half and a more recent half. Okay, it's just a very simple offset one. Then we calculate an estimate of our clock drift per T interval and then adjust the mean delay according to that estimate of drift. Okay, it does a reasonable job for what we're doing, and it also has the side effect of helping the algorithm where we have situations where the average delay is slowly dropping.
Hi, Brian Trammell. Clarification question. In the test that you've run, can you give me an idea of the magnitude of the clock drift that you're actually seeing?
So,
I mean, I know that clocks suck, but how much does the fact that clocks suck impact the metrics that you're seeing?
So, well, normally we haven't had a lot of clock drift in the experiments we've run. Okay, we have had some experiments where we ran over China. We did have significant clock drift, but the link was never reliable enough to actually run the experiments. So in the fix we did, this wasn't a huge amount of clock drift.
Okay.
So, but I think that that's probably all that's necessary.
Yeah, I mean, this looks fine for, okay, cool, thanks.
Okay, now decreasing the decision lag. Okay, with all measurement-based systems, you have a problem in that you're measuring what happened in the past to try to make decisions in the present that you hope will be good for the future. And so you have a decision lag. In this algorithm, it can be several seconds. Now, what you can do, of course, is take measurements in the future, but we're lacking the hardware for that. We can reduce NOM, so we can make our time shorter, but we can end up with less accurate measurements. Or we can exploit the fact that more recent measurements are more valuable than the older ones. Okay, we still need the older measurements for stability purposes. First thing that comes to mind when you do that is an exponential moving average. Really easy to calculate, but for our purposes, it has the wrong shape. It gives the wrong weights. It drops off really quickly at the beginning, and we want to add weight to the first samples. And it has an infinite tail, and we don't want weight to go on for that long. Okay, another common method is a linear decreasing weights. That doesn't give enough weight for the recent samples as well. So we've proposed a piecewise linear approach, which can be done incrementally. And because we're using integers as integer weights, we don't have any problems with rounding. So the idea is, this is an example with the skew-based one, and you can use it for the variance one as well. We have a period of flat weights, F samples for our FT periods, and then decreasing from there on down till we get to our M samples. And you would calculate that with weights accordingly. I'm not going to go through that in detail. But it's in the standard where the blue part represents the flat portion and the red part represents the sliding weights. And that gives you the stability you want, but also helps you adapt a little bit faster to changing network conditions. Now, our conclusions and further plans, I plan to put in the draft an outline of how the different thresholds specifically change how the mechanism works, define the sender-receiver interaction, and evaluate the effect of time resolution. We haven't done Wi-Fi tests at the moment. We've done some cellular tests, but not Wi-Fi, so we want to have a look at that. We hope to put these in a journal with the algorithm refinements and some quantitative tests as well. And we're also working on some other ways of grouping as well. So thank you.
Yeah, we have like 2 minutes for questions, if at all. Okay, but then we think this document is, we had a lot of positive feedback on this document in the past, so we think this is ready for working group adoption. So quickly, we would like to know who has read, what version are we on? 2. So who has read the latest version? Who has read any version? Okay, that's okay. So I think that's the basis where we can ask for adaptation. So if you think this document is ready for working group adoption, please hum now. If you think this document is not ready for working group adoption, please hum now. Okay, nobody humming. So we will confirm this on the list. Thank you.
Thank you.
Put the mic in
The next up is Scream, and you have about 35 minutes or 30 minutes for your presentation, including discussions. So.
Yeah. If you have an adapter, or you don't need an adapter.
Hi, my name is Jahid, and I'm working with my co-author Ingamari on Scream. And today I'm going to give you some updates that what we have been done from last IETF meeting, and some more like we have open source the source code, so I have a little bit information on that one, and then of course the recap of what we have been done with this Scream. I mean how you tested and all this thing, and see like if you can adopt. So basically, in the last IETF meeting and interim, we have been talking about like Scream talks about it's being a framework and all these things. So there was a lots of comments on that to restructure document. So we did that. We listened to you guys. So we removed the framework stuff. It doesn't talk about. So we divided this algorithm into sender side and receiver side. And then we have also updated the readability, and we have also simplified some of the equations, and of course we removed some of the functionalities. And one of the main objection was this frame skipping was a part of the algorithm, and we said like it was not. So now it's clearly not. It's added to the additional features. And also we have some issue list updated. So we have now described what is qubit means in Scream feedback message. And then, of course, we have some other updates. So one of the major changes we did in algorithm is like we changed the feedback message. And it's horrible to see. You cannot read. OK. But anyway, I mean, the changes was like there was like ACK vector. And the main area was to see at the sender, see what are the packets are missing and actually retransmit it. But we realized that RTP has its own mechanism of retransmission, so we didn't need to bother about that one. And we had very few benefits of having a hack vector, so we removed it. The another was like ECN echo, and that was replaced by number of ECN packet received from the last message. And this is to done like to get aligned with this ECN for UDP draft, that they have used ECN number of ECN CE mark packets, and also it is more robust on like when you have like delayed or lost feedback and some things like that. And also we have removed PT-RTP because we thought like when you have multiple sources you may need to have this thing in the feedback message, but we were completely wrong about that one because this source. This PT is available per source already in the RTC feedback messages, so we don't need to do that. So what are the main changes that we did on a functional point of view of Rmcat is like competing flows compensation. So we used to do like frame blanking and do this measurement during the frame blanking to update our condition window and stuff like that. We don't do that. So now what we do, we have a allowed target, and we have like normalized and variance. We look at the variance and normalization of this one-way delay, and if it is below some threshold, you're okay. Then fairness enforcement, we used to have a function dedicated to this one, but we found out that was really unstable in some cases. So now what we do is we had a simple principle of like, okay. We have this fast start, so we repeatedly do this fast start now and then. So I think in current implementation, if you don't see any, you are in a reduced rate and you don't see any kind of condition indication in terms of delay in packet queue length or loss, you actually go up and try to push up. So the philosophy here is like we made it a bit aggressive, and you'll see some results with that one, like this, that it works. So as I said, we have this resume fast start if it is nothing happening in last one second, and then you can actually push up your bit rate a bit. Then we are also changing. There are substantial changes in RTP rate control. We have completely decoupled the frame skipping stuff. Now we not only look at the transmission rate, we also look at the ACK rate, because in some time the reverse path could be congested, and in that case it's really really good to see like how you're actually getting ACK that then you're sending traffic. That's one thing. And then we also there was like RTPQ based the rate adaptation measurement, and then we found out in our simulations and a real life test like there is a few really short RTP standing queue. Whenever there is and there's a drop there, you will see, but it's not that much packet you can actually look at an RPQ delay. They don't stay there because you are adapting your sending bit rate, so you actually free it pretty often. So now we'll look at the length of the RTPQ instead of the delay. And what I will suggest whenever you are reading the draft, I myself have seen like a couple of anomalies that we'll fix it in the next version perhaps. But please look at the open source code. The source code is there. It is well documented. Go through it. It's not. We try to make it well documented and then basically compare it and let us know what you think about it. There are some values there, default values, and all this thing there, and those are based on our simulations and testing. So those, of course, could be changed. And I would suggest, like, Roland, if you have no question on that.
Yeah, I have just a clarification. I was just curious to see if you have any results on when you do this fast start, if there are any false positives in the case where you ramp up and you shouldn't have.
Well, the thing is, like, we're very cautious about starting it. We're looking at different variables. If you look at the code, it's not only like it's just 1 second you wait. We look at different variables before we actually make a decision to go up. So I don't think that there is chances of like false start on that one. It just automatically doesn't happen.
Okay.
Because there are other guard variables that actually make it viable.
If you've seen this behavior.
Yeah, no. But I can show you some results where you can see like the effect of that. Colin, on this slide.
Yes, I guess you're about to get into lots of details of results, so I just had a comment on the changes in the previous slide, if you want to take that now.
Yeah.
So you have some new feedback messages.
Yeah. Shall I go to that slide?
If you wish. If you look at our RFC 6679 ECN for RTP, I think a lot of this information is included in the feedback messages that are in that draft.
Yes. In a sense, yes. Yeah. You can say that. I think the timestamp is not there. That's actually
I think everything except for the timestamp is there, and a whole lot of other ECN information. So you may wish to try and align things, or use that feedback message plus.
Yeah, I think we have it here because of this timestamp, because that is what actually we need to really to be functional. And I don't know, like, if we can. I don't know, like, how to combine to use 2679 to 2679, right? 6679. Sorry, 6679.
You may just be able to use that and piggyback a second feedback packet into the compound message.
Okay.
Don't know. But I'm not saying you must use the 6679 format without change, but you should at least look and see if you can.
Okay. So here you can see like this RTT fairness test, and on the left it was 03 version, and on the right it's a 05 version from your side, of course. And you can see like there's some fairness, but of course you see a bit more jittery waves here, and that's basically we're actually pushing it a bit. Previously we have been doing the frame blanking and stuff, but we also have like condition inflection points and stuff like that. So I mean, to us it looks pretty like an improvement, and it is more stable than what we had before. So we're going to stick with this one, I guess, unless somebody finds a really good bug on it.
One quick comment. Sorry, one quick comment. Notice that the colors seem to be diverging. Can you confirm that it's not going to go in?
Yeah, I mean, well, if you change the timeline here, I think what you will see in the middle on the 1680s, you'll see the same thing.
So it's not going to diverge?
No.
Okay.
No. I think actually we run it on 300 millisecond, 300 second, but to compare the results, I just cut the results there. So because 05 is run on the new RTT fairness new version of it, so that has like 300 second of length of simulation. But I think to compare it, I just got it there. And I have not seen that. No. And here is the, oh, I mean, yeah, so the competing traffic with the long late TCP, it looks like a bit better with the new version of changes. And that's what we try to do. We got some hit on like when you have a free link, you know, run a simulation on like free link, then we see some issues with these changes. But actually, if we one has to really like trade off here what we want to do. And what we found, like when there is a TCP on the link, now we can see actually some throughput up there with a reasonable delay, like 500 millisecond delays. So that's why we are actually skimming up all our previous frame ranking and stuff like that, and we stick with the new aggressiveness of this algorithm. So I made a comment on this mailing list, like at the end of the day, I think we may actually, to be future-proof, we need per packet feedback. And I think I need to clarify my stand on that one, that this is not true for Scream. And in Scream, we can handle some kind of sluggishness on it. We don't need actually per packet of feedback in Scream. So basically, the reason is like that. Like if you look at the right figure, you see the condition window, and then you also see like you're not actually filling it up. And that is what actually we were saying when I presented something on a spot, like in the real-time communication, you don't do that. You can actually measure some condition on window, but actually for real-time or a rate-limited application, you have some headroom. So basically the theory is like we're not sending as much as we should. And basically we can actually survive some kind of packet delay and losses. And these values, I want to just have you just have a look at it, but don't. That's like very rough recommendation. Just looking at the figures, you can come up with that kind of report. And this is what to show, like, yeah, I mean, we run this simulation with 20 millisecond RTT interval, and you can see like until 10% packet, you don't go that much throughput down. So yeah, just to show like, yes, we can handle some delay and packet losses on the feedback, and that's a built-in feature on Screen. So now, yes, we have from Ericsson Research, we have open source the Screen code. I think there was like, I think their thought was really to get the code, and now we have it. So fork it, clone it, get involved, make it better. I think if you work with it, I think we can really do a good job here. But there are things to be noted. This code is experimental, so and then basically all the constants and constraints in the code is like to do like quick experiments. It doesn't do anything in RTP or RTCP functionalities or RTP queue. So if you want to use it with your real implementation, you have to work with your packet queues and stuff like that. And we have also included a very basic functionality so that you can simulate some link, just reading some data from the file. So you can simulate some link. It's in there. It's already there. So just to like you can try it out that our figures, what we're showing or what we're doing is really good or bad, or give us feedback on that one. So what actually you should look at, the main Scream algorithm is in Scream TX and Scream RX. The TX is of course the sender, is the biggest part. I think most of the code is there. And the RX part is the receiver part, and it's a very few code there. And there are some supportive classes like rudimentary RTPQ. Then we have a video encoder. We just have a simple video encoder model there. Then we can add some sluggishness and stuff like that. And then you have like net queue, simple delay, and bandwidth limitations. So you can simulate some bandwidth impairments or transport impairments on that one. So I hope it's useful, and you can see and give us feedback and get involved on the evolution of our Screen. And yeah, I know, animation. And this is the slide where everybody warned me that you guys will not take me seriously. I hope that's not true. But I just found it really cool to look at. But it's Scream. I mean, it's robust and efficient. We have been showing results. And we have been tested with where the basic test case we have tested with our cellular test case, of course, and we have some rudimentary model of Wi-Fi that we are trying to do. This is just recapping what we have been showing you last almost 1 year, and we also have running codes. That's important, right? We have running codes, and you can have a look. And this draft, I think, is quite mature right now, and I don't think you can read it, but that was not intentional that an open WebRTC integration is going on. So hopefully we'll be able to release it pretty soon, and then basically I think in months, you can count it in months, and then basically you can try it out in real encoder like H.264 or some VP8. So that's it. I mean, so what I'm going to maybe I will ask it. Right? Okay.
Yeah, I mean, first, if there are questions on any of the content.
Of course, I've been following the work. I was just wondering, are you guys planning to do any, so all these are simulation evaluations, right? Are you guys planning on testbed sort of real network-based
But that's what
evaluations?
we're working on. I mean, this open source code, you can actually run on, you can take it, put it out in any web browser and run it on real life. So that's what we're trying to do. We will have open WebRTC integration, and basically we would like to test on real LTE network, real wireless network, or real wired network with this. I think the basic principle is use this basic test case in a real lab and see. And we have been doing that, but as we don't have any integration yet done completely, so I think next time I can show you some results on that.
Just as a side remark, so to have this as an experimental RC at some point, I think it's okay to have results which might be only based on simulations which actually show that it will not break the internet. That's the most important point.
Exactly.
Just another question out of curiosity. Does the Open WebRTC currently implement any congestion control, like Google congestion control?
No.
So it doesn't have anything. Is there plans to be able to plug in more and somehow?
Then you're asking some wrong questions here. But I already said we'll integrate the Scream in it. Okay. And hopefully we'll make open WebRTC in such a way that you can actually plug in some other stuff. But mostly we'll focus on Scream.
Karen Nielsen, as an individual, have you tested Scream in environments with packet reordering?
Packet reordering, yes.
Yeah.
Yes.
But you just...
Yeah, I think I know your concern about like packet reordering and stuff. How do you make this loss and stuff? But we do it. I mean, we do testing that we do like 5 packets. So, but yeah, I mean, but we did do quite large bunch of packet reordering. I think we did that.
That may also be an issue that perhaps comes up in these wireless test cases, because as I understand, there are generally more packet reordering in the wireless environment than in the wired environment. I just checked the requirements draft, and actually there's no explicit requirements for packet reordering. Have you, perhaps as a test case also, can you comment on whether there are test cases specified for packet reordering?
I think we had a lot of discussions on packet reordering on the mailing list, right?
Yes,
and we thought like this is I think jitter and packet reordering. So we try with lots of jitter packet.
I think perhaps we as a working group need to think a little bit about whether it's something that we've specified in our documents. But that's
even
just
in the test cases
comment.
that we explicitly say we have this kind of reordering.
Yes, exactly.
Okay.
At least we need to think about what we want to do. Given, I mean, for example, one have just there's consensus in TCP working group that TCP should be robust towards reordering. I think we just need at least to think about what we think about the Rmcat congestion control, to which extent it needs to be robust towards reordering.
Yeah, but if one thing that we have to remember, like we also have this RTP transmission and reordering handled by some, I mean, you can also have fakes and stuff like that. So it's not really, I'm not really sure, like we have to stress that point, but of course, I think we had discussed this one. It's not on top of my head right now what has been decided. But
I'm not trying to stress it as a showstopper or anything like that. I just wondered, the thought just came up.
But yeah, maybe some words in the test case would be good, whatever we decide.
Okay, Magnus Westlund channeling Randall Jessup. He asked to contact Mozilla, him, about possible test integration with Firefox.
That's really great. Thank you, John.
Okay, if there are no more comments, I actually would like to go to ask for adoption. I think last time we discussed this document, it was already a lot of support for the document. The main concern was about structure of the document. You applied a lot of changes, so I think this is ready. And I would like to get the feedback from the room. We again do a hum. So if you support to adopt this document as a working group document, please hum now. If you are against supporting adopting this as a working group document, please hum now. Again, no hums again. So confirm this on the list and
Thank
go
you.
on. And then next it's shouting. Randall supported adoption as well. Great. You need to plug in your computer.
Okay. Yeah. So I guess that. Yeah. So just to want to give an update on the other candidate solution, NADA algorithm 2. We've updated the draft. So if we move on, as yeah. So don't worry about it. I think yellow is a pretty color too. So yeah, either one is fine, and it keeps people awake. So yeah. So basically, for this presentation, I'll give a brief update on the draft. We did update the draft, sort of lagging behind our presentations typically, and then an updated simulation results for the basic test cases. I've actually have a separate slide, set of slides on. We've also evaluated NADA interactions with various AQM spins, but I believe maybe today we don't really have time to go through that. So some goodies
Actually,
for.
we catch a little bit up, but still.
Oh yeah, let me try to see how fast I can speak. So, and then also wanted to share some updates on the testbed-based evaluations. So those are, sort of evaluations over real networking, sort of real network gears at least, and then summarize open issues and next steps, and obviously asking for adoption is part of the next steps. Next slide, please. So basically, for the draft, we have the major updates are on the descriptions of the main congestion control algorithm. Most of the algorithmic updates we have presented at IETF last time in Honolulu. Basically, we've introduced new features in terms of nonlinear warping of the delay at the receiver to be able to compete more sort of resiliently against TCP flows, as well as accelerated ramp up at the sender. And in addition, in this new draft, we've added more detailed descriptions on the receiver behavior in terms of how it handles delay loss and packet marking informations, and how it performs denoising estimation, as well as estimation of loss and marking ratios. And so I welcome people to revisit the draft. And finally, some minor updates in terms of, sort of update on implementation status, fixing typos, so those type of stuff. Next slide, please. Now, then we can just jump directly into going through all the updated results on basic test case evaluation. This is mainly to address one comment from last IETF meeting in being basically we want to add a delay jitter in our end-to-end sort of measurements. So now we've added a uniformly distributed delay jitter in the same way that Scream has been carrying out its evaluations, and also as specified on the current test case draft. Next slide. This is the list of test cases. The only tweak we added is that for the third one on trying to evaluate the algorithm behavior in the presence of congested feedback, in addition to looking into bidirectional cars, we also added a new case where the backward channel is basically sharing a TCP backward flow, which potentially introduces losses as well as, a full queue along the backward channel. Go ahead. Next slide. And then this is just a list of algorithm parameters. It's probably pretty meaningless to go read through them right now, so I invite people to read them offline when you, sort of when you have a better notion of what these parameters refer to in the algorithms. They're all highlighted in the draft too. Next one. So now we can just try to flip through the test case. If we go fast enough, we will get to some more evaluation results as bonus points. So basically, for test case A, this is the single flow over variable bottleneck bandwidth path, very similar to what we have presented before. The only thing I want to highlight is that now when you look at the delay graph, we basically plot individual delay measurements as dots, and because we have added the delay jitter, you now see a band of delay measurements going along, as opposed to the previous one with very clean sort of, delay variations. And obviously, when the bandwidth drops at time 60 seconds, the algorithm does not have an opportunity to react until it gets the first feedback, and that feedback gets delayed too. So that's where we do see, sort of a burst in, a spike in delay as well as instantaneous packet loss ratios. Next one, test case B, basically repeating a very similar scenario but playing out with two flows. The main thing to highlight is that with our algorithm, the two flows share their bandwidth very equally along the way. And similar behavior when bandwidth dips very, sort of abruptly at certain time instance in the simulation. Next one, test case C. This first one is just to show the bidirectional flows. Actually, we can just look at this one and the next page, the forward path and the next page, the backward path. The main message is really to see that the presence of a basically bidirectional cord, the presence of a backward flow does not does not interfere with the congestion control algorithm. All the bandwidth throughput calculations as well as delay behavior remain somewhat uninterrupted. And then the next one is a new case that we're trying to challenge ourselves a little bit more by introducing a TCP backward flow between time 30 to 70 seconds. So during this period, you do see that because of the presence of TCP along the backward channel, some of the acknowledgements are now coming in much later and maybe occasionally get dropped. So there is a minor sort of, more variation in the calculated rates. But obviously, the forward delay measurements don't really show up too much. And again, in this graph, because we're not doing the bandwidth dipping because of the the dynamic range of the y-axis, the band of noise along the delay that we have introduced is more obvious. It's basically a band of noise over 30 milliseconds. Next one. And so now we're moving on to looking at cases where we have multiple competing flows. This graph just shows the trace of the individual ones, flow 8, 1, 2, and 3, as well as their respective delay measurement. Next slide shows a summary of their respective flow rate as well as their one-way delay average value, as well as arrow bars showing the standard variation of their measurements. These are averaged over just the stable steady state period of the previous simulation. So as we can see, pretty fair sharing across 3 flows as well as reasonable variations, both in terms of delay and rate. Next one is test case E, where we are basically repeating the same test, but introducing different amount of path propagation delay across the 5 flows. So the different one-way delay, they are staggering up, shows very clearly on the bottom delay graph, whereas on the top graph, we do see that the mechanism of NADA ensures that they would be able to share their bandwidth fairly at steady state. So this one summarizes again the average delay and rate sort of averaged over the steady state period, as well as their standard deviation. In this case, we do see some delay variations. So the standard deviation compared to the previous set of results we presented at IETF 91 becomes slightly larger. But as you can see here, right now, the queuing delay are still confined around 30 milliseconds with maybe 10 milliseconds of standard deviation. So we still consider that as very acceptable. Next one. This is the case where we're basically there is a TCP flow in the middle of the Rmcat flow. So basically, with the additional features that we have added into the algorithm, we see that basically we can have fairly fair bandwidth sharing in the presence of a TCP flow, despite of the high queuing delay it causes, and also the fairly spiky packet loss ratio that TCP flows introduces to the NADA flow. Next one, test case G, as Varun and Zahid pointed out earlier, we're still, I guess, trying to maybe revisit the design of this test case where two Rmcat flows competes over a collection of short TCP flows. This one, basically the way I carried it out is just by randomly placing out a TCP flow, one or two TCP flows with a duration, on the order of tens of seconds, and see how the two NADA flows react to them. So this is more like showing the end result of the NADA flow rates and delay profile over time. Yeah. Next one, media pause and resume. This is another test case being specified in the draft. Question?
Clarification question, Jahid.
Yeah.
In this slide, I mean, this losses is coming from like buffer overflow, or there is a AQM in the past?
Presence of TCP. So this is...
No, in this simulation, have you used any kind of AQM?
Oh, this is drop tail.
Drop tail. Okay,
yes.
so it's a buffer
So throughout all the basic test cases, there's only drop tail.
Yeah, okay, thank you.
Yes. Okay. Yeah, and this is the case where we have a media pause and resume. So in the middle of the car, the second stream is paused for 40 seconds and resumes. This is just to show. And I know your question, and I can answer. So you had the same question from last time, right? Go ahead.
I actually don't remember the last one.
Okay.
But actually, it's for the previous slide. So.
Okay, sure.
The question was when you model the TCP for this fixed amount of time, were they actually downloading a certain amount of data, or were they just on for that period of time?
They were just, so basically it's the FTP traffic source in NS2, and it was just on for a given specified time period. Yeah.
That's actually slightly different from how, at least I envisioned the TCP case, where they would try to download small segments for they would try to complete whatever task they were given.
Yeah, sure, but I don't think it will. Yeah, since we randomly sort of specify the time duration, yeah, I don't think it will make. And then the next one, in case you're wondering, I think last time, Varun, you were wondering, basically for the second flow, the way we restarted, it basically restarted as a new flow, so it did not resume its previous rate memory. Yeah. In practical system, it might be easier to do the later. Yeah. Okay. So that's actually, yeah, go ahead. Next slide. So that actually has completed our update on, or sort of rerunning all the test cases, evaluations with random delay sort of jitter noise present in the measurements. So in addition, we have carried out some more testbed-based evaluations. So this is a fairly clean lab setup with a real router in between the sender and receivers. The sender and receivers are actually VM-based Windows applications, just because it's easier to carry out that way with a bottleneck link of 2 megabits per second, no additional path propagation delay, but also a provisioned queue with a queue depth of 500 milliseconds. Our update with respect to last time is that our Windows-based implementation of NADA this time has finer granularity in its timestamps, both in measurement and in scheduling of traffic transit.
So you're using Windows clients on a Windows VM host?
Your name, yes.
Oh, sorry, I'm Brian Trammell. What is the timing resolution that you're using in your measurements?
So you mean our measurements are?
Yeah, so the timing, or the resolution of the timing, are you doing, I mean...
On the order of maybe a couple of milliseconds. Yeah, so our previous presentation... Yeah.
Yeah, so there's a lot of timing jitter in doing this VM-based, just to make, I'm sure you're aware of it, but I wanted to make, okay.
So our just to recap, our previous presentation at 91, the Hawaii
which I wasn't
meeting,
at.
Yeah, at that time we did encounter timestamp granularity issues. The timestamp was basically on the order of, the granularity was 16 milliseconds. That kind of, harshly quantized our measurements. This time we were able to fix that problem.
Okay. So I would suggest doing this with doing it with a different VM host, like maybe Windows VM VMs on Linux host,
Yeah, okay.
just to make sure that the VM itself isn't injecting systematic timing error.
Yeah, good suggestion. Thank you. Next one. And in terms of result, instead of carrying out the whole array of scenarios, we picked 3 key ones that we think are most we care about the most. The first one, obviously, is more as a sanity check to show that it works well, a single flow over a single bottleneck link. In this case, the bottleneck is 2 megabits per second. Our max rate for this application is 3.6 megabits per second. Next one, and one we also show that it works well when we have 2 NADA flows sharing the same 2 megabits per second bottleneck link. You do see a little bit of a bias when their rate stabilizes, when they compete together. That is because when the second flow, the red one, enters the network, it already observes a standing queue, and from that flow's point of view, it mistakenly takes that part of the standing queue as its estimation of the propagation delay. So we do observe this type of a slight deviation from equal bandwidth sharing in real-world setups. And next slide is the case where NADA competes over TCP. In this case, this part is where we're continuing to trying to hone our design parameters better. In this case, for instance, we see that NADA yields to TCP, but not too much. There's ongoing investigations in how we are trying to calculate packet loss ratio, as well as how we are trying to, integrate the component of packet loss ratio into our the composite congestion signal that NADA reacts to. So this is pretty much ongoing work. We just want to show that it stands its ground in the presence of TCP. Overall testbed 2. Go ahead.
Jahid, another clarification question. This PLR, as it is too high, is it like combined TCP and RTP? I mean, where you're measuring this packet loss rate? At the endpoint or in the queue?
So this is measured at the endpoint.
So it's about
what
this
the
is
Rmcat flow observes. Yeah, and
okay.
It's a simple, windowed packet loss ratio calculation.
So how does this value looks like when you look at the TCP flows?
For TCP, in this case, we just run the iPerf as the competing TCP flow. So we don't really have insight into what it observes. Obviously, if we do our own, packet capture, we will be able to find out that information, but not for this, right now, not for this experiment. Yeah.
I mean, my intention is to know like whether Rmcat flow was able to push a bit up, to push these TCP flows to create a loss, and then it reacts to that one or not. Because in our simulation, we have seen something, because we have not seen this much loss in the Rmcat flows.
Yeah, so it really depends. So when you think about it, in the end, the Rmcat flow is a RDP flow, right?
Yeah.
And your rate calculation tells you how much to send. So if you could configure it to be really, aggressive, and so that TCP yields to it, you could also configure it to be very, how should I put it, like very graceful at, reacting a lot to losses and delay, and therefore get starved by TCP. So there's a kind of a range of operation you could choose from. We're still working on tuning what's the optimal operating point. In fact, I have backup slide showing an alternative performance of this experiment.
Yeah, I'm just trying to understand, like when this drop on the, if you may, in the IT segment, when this drop happening, is this because of losses, Rmcat reacted or reacted slowly, or?
Yes. So as you can see, the drops in the rate kind of correlate to the spikes of the packet loss ratio.
So it doesn't react to the delay or something? Because delay is also quite high.
Well, no. Okay. I mean, if you react to delay up to 500 milliseconds, you would get starved by TCP. That was the whole point of the non-linear delay warping that we have introduced into the algorithm.
Oh, okay. Yeah. So you have delays and losses, basically.
Yes. So okay. You basically react to both. Yeah. Go ahead.
Also a clarifying question. So this looks like the TCP is TCP Reno you're using here?
TCP, sorry?
Reno?
Reno, whatever iPerf uses in the Windows, command line
Windows
program. And it's Windows 7, so.
And the simulations you did before?
In simulations before, we used TCP SAC, I believe, one of the NS2 modulars.
Okay, I was just wondering because it looked quite different from the simulations result, this curve.
Yes, yes.
And it seems that the congestion control you've been using in the simulations was more aggressive. And in this scenario, it seems like actually NADA is more aggressive and pushes away TCP from time to time.
Yeah, but keep in mind that in our simulation setup, the sort of the choice of the bottleneck bandwidth as well as the dynamic range of NADA was also different from this one. So this one, the NADA has a higher sort of max rate. That kind of also plays into how much it's striving to get. Yeah. So those two are not side by side, sort of not side by side comparable. But addressing your point,
the max rate is a configuration parameter, or depends on the
it's
video
a
traffic?
configuration parameter. Yeah, the reason why we chose it in this Windows application is because it was derived from some other applications which were aimed for higher resolution video. So that's why it had a higher max rate.
And are you planning to, at the end, propose or recommend one certain set of parameters?
Oh, you mean the max rate? We believe that should be an application input. So I guess leaking into the discussion of.
But the other parameters were like the parameters which actually determine how aggressive NADA is, they've been the same then in the simulations.
Oh, I see. So let me put it this way. So our understanding is that the dynamic range of the application should be determined by basically what type of video this congestion control algorithm serves. So it should not be tuned as a parameter within NADA. It should be given. Now, there are other parameters you could tune within the congestion control algorithm. For instance, how much weight you want to add, sort of assign to the loss ratio as a component in the overall congestion signal. Those are additional parameters you could tune within congestion control with regard to its aggressiveness.
And that was the same set of parameters for the
So yeah, so those set of parameters we have not changed. Sorry, but I get your point. I think next time maybe we should strive to provide side-by-side results from simulation and testbed. Okay. Next one. Yeah, so next one is actually more, I guess it's good to pause now in case we run out of time to summarize the list of open issues and still sort of ongoing efforts that we're still working on. Basically, we want to acknowledge that even though we have introduced a good mechanism for NADA to react to loss in the presence of TCP, okay, sometimes we do observe that the switching between loss-based mode, sort of the implicit switching between loss-based mode and delay-based mode are not, working 100% of the time. Sometimes it may get locked in a loss-based mode. So we're still working to resolve that performance issue, algorithm issue. And then as any delay-based algorithms, the algorithm is also fairly vulnerable to mistakes that shows up in the delay measurement. We strive to do our best for denoising, correcting for clock drifting, etc. But we just want to call it out that we believe any of the delay-based algorithms are susceptible to mistakes just because clocks tend to suck, I suppose, over for certain devices. And then right now, the other issue that has been, we've been carrying over but have not got time to address is that in the absence of an acknowledgement of feedback, the algorithm or the sending rate would persist, and that may introduce high congestion over the network. We do need something similar to TCP's timeout mechanism to handle the absence of feedback. Right now, all the changes are triggered by feedback only. But we believe it's, there are many ready, components that we can borrow from to augment the overall performance of the algorithm. And finally, right now, the denoising filtering, this is maybe a minor issue, the denoising filtering that we have introduced into the algorithm tends to slow down the overall congestion control feedback loop. So we want to see whether we can, improve the reactiveness of the algorithm again. Yeah, so these are more like the open issues of the NADA algorithm and solution. And some of the ongoing efforts include investigation of alternative ways of packet loss ratio calculation, as well as coming up with good guidelines on how to choose the design parameters within the algorithm. And finally, we are interested in, testing it out even more extensively with live video feeds over wireless setups, more noisy network environments, etc. And now that the Scream source code is out, we're definitely interested in looking at performance comparisons across candidate solutions. And finally, the call for action from the working group is we would like to ask for adoption of this solution as a working group item so that it's a more like a draft intended for standard track. And finally, any feedback and suggestions on the draft and evaluation efforts, what type of tests we should run further, are always welcome. Thank you.
Just to clarify quickly one point, so this would be, the intended status would be experimental, because you just...
Sure, yeah, experimental.
Do you have enough time? Do you want to show your AQM results now, or you want to ask for adoption now?
Should we do that just so that we get first things first? Yeah. Ask for adoption
Okay.
first, and then we can show more results.
We detected that you actually described some AQM mechanisms in the draft as well. In your draft, you described the AQM mechanisms you are using. As we are not chartered to specify any AQM mechanisms, probably we would like to ask you to remove them from the draft. You could move them probably, I mean, like we are also have a milestone where we want to document evaluation results, so you can probably start a new document over there, specifying or describing some simulation results. Is this something that you would agree to?
Yes.
Okay.
Yeah. So just to clarify, the performance of sort of the operations of NADA does not depend on the network node operation. In fact, that was one of our design goals. We want the behavior of the algorithm to be agnostic of what happens over the network. We included those network node operations there just to illustrate. If you have a better AQM schemes, you could get better performance out of NADA. But I guess it makes more sense to maybe for now move them to appendix or move them to the test case. We can move
One
them
of
to
those
test
is
case.
fine, basically.
I think I have the follow-up question as to whether is these AQM specifications something that we want to have in the evaluation criteria or in the test cases? I mean, it's a question to the working group. I mean,
I can have a quick reply because as co-author of that test case draft, we do have a placeholder for use cases with AQM because while it's, you know, design of AQM is out of this charter, we also don't want to come up with a solution that breaks down in the presence of red. So, yeah.
Jahad, yes, I think in the last IETF meeting we have, in the slides, I think we have a bullet calling like whether we really need an AQM. But then there was discussion, and I think there was like no, kind of like my conclusion was like no, there is no need for it now, but we still have, as Shamsin said, like we have a placeholder. If it pops up to be really important, yes, we can add it. Otherwise, so far, my conclusion was like there was not that much to add about AQM test case, because that's like a configuration thing. All the test cases could be run with AQM. That's a one line could be now could be added, not like a specific AQM based test case.
Yes, concur on that.
So, Randall Jessups want to state, if I recall correctly, we mentioned AQM in the requirements.
Matt Mathis, I think placing requirements in the network are sort of out of scope here, but it's actually fundamentally important that the protocols shed some insights onto what's missing in the network. So, for instance, no AQM, long queue, and TCP cross-traffic is completely hopeless. You add AQM to that and it gets better. You add queue segregation to that and it gets a lot better. And somehow, one of the lines in the charter is about somehow exposing that information so that people at least have an insight about what it is that they need to do differently to make it get better. This is where we provide the incentives for people to accurately complain.
So, I mean, yeah, so I got some feedback that we at least should integrate those in the test cases. But I think for now it's actually okay to just, before we adopt the document as a working group document, to either remove it in the appendix or to move it to a new document. Yeah, I think that's needed. There are no further comments. I'd ask for the adoption.
Varun Singh, I was just pointing to the eval criteria testing. So as I suggested, it's possible to just say AQM is turned on for all the test cases or some subset of it, and that's sufficient. The AQMs themselves could again go to eval criteria because there are models there. They could also stay in the appendix of NADA's draft, which does not affect the outcome of this decision to do so.
Randall Jessup says there's this requirement 11. The algorithm should be stable and maintain low delay when faced with active queue management algorithms.
So, and I think the idea we have is that we want to test those candidates with AQM. The question is only if we specify AQM parameters somewhere that should be used for the testing. Right? Right. See nodding. Anyway, so again, so the question which shares is to move this section somewhere, and if that's done, we would ask for adoption of this section of this document, of this new version of the document where this part has been moved. So that's just an editorial change. It doesn't change the content. So I think we can ask for an adoption harm right now. So everybody who thinks this document is ready for adoption, please hum now. If you think this document is not ready for adoption, please hum now. Again, no hums against. So we will confirm it on the list, and you just go ahead and submit a new version as soon as possible, just moving the text. That's all. Yep.
Yeah, if you can make use of 5 minutes or 7, yeah, up maximum 10.
Sure, yeah. So I just wanted to, so this is actually a pretty dry collection of slides. Just wanted to flesh out some of the earlier AQM interaction evaluations we have carried out. Next slide, please. So basically, the test setup, we have carried out 3 set of results: single flow, 2 flows, NADA versus TCP in the presence of AQM. Next one. Network setting is fairly similar, except that we realized that with AQM, some of these like pi and cutoff, they try to target a fairly low queuing delay. So it doesn't make sense to test them over a very low bottleneck link with very big packets. So we changed the setup to have a bottleneck link of 4 microseconds, but adjusted the available bandwidth for the Rmcat flow via the presence of UDP flows. That was the main change with respect to previous test cases. And then all the other parameters are fairly similar. Next one, for the queuing schemes, there are 4 queues. We try out job tail is more as a, sort of as a background, as a base of reference, and then the red, pi, and cutoff. So for both pi and cutoff, we choose the target delay to be 20 milliseconds. For red, we basically pick the minimum and maximum threshold in the red queue to be 20 packets, sort of below the maximum and also above 0. Go ahead. Next one. This is again the same set of algorithm parameters that we have used in the previous set of basic test case evaluations. Next one. In the single flow case, basically in the middle of the session, we bring up a UDP to squeeze out the bottleneck bandwidth from 4 microseconds to 500 kilobits per second. Result. Next one. So now I'm going to flip through the result. This is actually one exposing the problem that sometimes, sorry, the previous one.
It's slow. No.
Yeah. So for the job tail, I do want to highlight that this is actually a bad result in the sense that once the UDP flow comes up, the NADA flow gets pushed into the loss-based mode, and right now it doesn't have a good mechanism to come back, and that's an active working, sort of issue for. That's an item that we're working on right now. Next one. And then for all the AQM-based results, as you guys can see, we can adapt well in terms of the available throughput and also have a standing packet loss ratio. For red, I believe the previous peaks are too high. There should be some standing packet loss ratios and a standing queue, but a much lower standing queue due to the merits of AQM. Next one with pi. So again, this is the band of delay have a band of noise with 20 milliseconds, but in the presence, in the middle of the simulation, when there are, when there is a standing queue, typically both pi and cutoff. Next one, cutoff shows a more tight sort of control of the queuing delay versus pi, but their average queuing delays are comparable and with some residual packet loss ratio. Next one, the next set of results are 2 flows, very similar. Basically, the 2 flows share a bottleneck available bandwidth for 1 megabit per second. The rest of them are taken by background UDP flows. Next one. And then we can probably just flip through the results since there's very similar setup with 2 streams. And in this case, we haven't yet with Jobtail again. Maybe there's some kind of sort of a deterministic packet job pattern that gives them very different packet loss ratio. Again, this is a case we need to address. Next one. With red, we see very fair bandwidth sharing. And next one. We can just flip through. Yeah. Pi, similar packet loss ratios. And again, I guess the main thing is just to show that they can share their bandwidth equally. Next one. Cutout 2. Yeah, next one. So the final set of results are NADA versus TCP. If we go to the slide.
Sorry, that is late.
Oh, yeah, I know, it's a bit slow. Can you try again? Oh. Yeah, so here basically 2 NADA flows, 2 TCP flows sharing a 4 megabit per second. The TCP does, yeah, that's okay. So basically, in the presence of Jobtail, TCP does drive up the queue, and the NADA flows are pretty aggressive in this case again, so they get a higher bandwidth sharing with respect to TCP. Next one. It's slow. Yeah, red, that's fine. So red, we can just flip through them because most of them, they show that you can trade off your congestion signal with a lower delay but with some residual packet loss ratio, and that would give you the same amount of bandwidth from NADA flows. Pi, yes. And next one. Cutout, yeah. So that's actually the collection of kind of first results we have gathered on NADA over AQM interactions. It exposed some problems. There's, but I think those are good leads for us to further improve it. Go ahead.
I'm not sure if we can go back to the slides on 2 flows. Basically, any of them like Pi on 2 flows or something. You said that Pi had a target rate, like for example, this one. Yep. Pi had a target rate of 20 milliseconds, and I can see delays here of up to like, or like in medium around 100 milliseconds. Can you explain or
Sorry, I forgot. Can you repeat your question?
Yeah, so Pi is configured, so that's a Pi slide, right?
Yeah, this is Pi.
And Pi is configured to have a target rate of 20 milliseconds, you said, right?
Target delay. Target queuing delay of 20 milliseconds.
Sorry.
Yes.
Sorry, target delay. And the delay, the average delay you can see here on this plot is around like 100 milliseconds.
That's the additional measurement noise that we have added. So we've added, okay, so first off, this delay graph shows the one-way, how should I put it, like one-way delay, and there's a one-way propagation delay of 50 milliseconds. That's why we're showing sort of only 50 and above. And then there is delay noise, additional jitter, uniformly distributed 0 up to 30 milliseconds. So all the delay graphs have a band of noise of 30 milliseconds. Okay. That was per kind of a suggestion from the basic test case.
Thank you.
But in general, since Pi does its dropping at in-queue, its control of the queuing delay is a little bit loose compared to cutoff. That was the main observation we had. Yeah.
Okay, thank you. Any questions? Yes, so then we have plenty of time for our last presentation.
Okay, I'll take it like this. Right, so this is an update on coupled congestion control. We were asked to work with the mechanisms that are being proposed for adoption here. I will start by saying that I understand this requirement, but even seeing these updates now, I would like, at least like to not be required that to have that mechanism work with all, or like with both mechanisms, because every time they change, and changing requires us to change this. So it's not just running the simulations again, it's updating how we apply the coupled congestion control mechanism to it. Okay, already I got a question.
No, perhaps this is a clarification thing. I mean, my understanding on having this exchange, kind of like couple control, is like so that you don't have to change too much.
Yes.
Irrespective of what algorithm we use, but you just say like you have to change. But
A little bit.
Yeah, but
very little, but we need to, like every time, investigate what has changed and see if it can be just blindly applied. I'll explain actually in the case of NADA what we saw from one version to the next.
But
it's not much, but it needs looking into it and figuring out what happened.
But don't you think like that's like a downside of this kind of approach? Like you have to
No, because
adjust.
it's the minimal thing you can do. You have to do something. You can't just take it and, I mean, you have to do something.
But
it's
my
the minimal.
understanding was like the session exchange, like what do you call it? The mechanism where you register your what is it? Name exchange, some exchange, right?
The flow state exchange.
Flow state exchange, yes. I was thinking like that is there because you want to actually avoid this kind of thing. Like, well, we need a system where you don't need to adopt to anything. It's just a simple.
That's impossible.
That's impossible.
That's impossible. You have to change something about the congestion control to take the rates and change the rates, and you need to know what you change. And if you simply just take the output rate, for instance, in NADA and change it, it goes wrong. You need to know what exactly you're changing. It requires a little bit of a chain of knowledge about how the mechanism works, and a little bit of looking into the mechanism, but it's the minimum that you need to do.
Okay, so you're saying like tomorrow if somebody comes with another algorithm, then this...
Every time you need to take a look at the algorithm and at least have a reasonable update to it. And so we're trying to, in the next update of the draft, we're going to make recommendations that are as general as possible based on the things that we learn from applying it to these algorithms. And we're going to say, okay, if this and this is happening in the algorithm, you have to take care to change this accordingly. If this and this is happening, you can't just blindly apply it without changing anything. That cannot work.
So I think even if we have to confirm it in the mailing list, but I think two of these proponents have been adopted. So you have a plan to show something that how much need to be done on using both. I think you are going to show it NADA with this screen also. Because that's what you need. I mean, you just say like you need to do it. So I think anything.
So my request is not to have the adoption as working group item depend on having results with both NADA and Scream. Because both are
but you
changing
just say
every
like
time.
You need to change something. That's what I'm asking. Do you
I don't know
really
what I need to change about Scream. We have to look at it. I haven't done that yet.
But you say that you need to do it.
Yeah, every time with
so
every
that's why
mechanism.
I'm saying
Otherwise,
we need
that
to show
cannot
some
be done.
result for us this Scream before we do say anything about it. Or we need to come up with something that is more generic, that it
Cannot.
doesn't matter.
It's not possible. I'll tell you. It isn't possible. You cannot just take a rate and divide it without knowing anything about the algorithm. It just doesn't work. It's not. It cannot be as general as that.
But
We're making
I
it as general and as simple as possible. It's what you're asking for is not possible.
But so far what I see in this draft, that there is no kind of information exchange between the flow state exchange and the real application that's using it that says I'm using NADA, I'm using X, or I'm using Scream. There is no kind of information. So what is the information you need to do the modification? That's not there. So you just implemented NADA with
the
this
algorithm
one
is
screen?
described with inputs and outputs, right? So I say we take a rate and we give a rate back.
Yeah, that's
right?
what you do.
Right, but what variable is it in the algorithm that you feed in, and what variable is it that you feed back? That is something that you need to look at.
But then basically you're saying like this mechanism needs to tell from the algorithm, the application to need to specify I'm using Scream. These are the algorithm things you need to know.
Okay.
I don't see that in the
Let me
draft.
give you an example. NADA does an update every 100 milliseconds. It sends a feedback message. Okay.
Yep.
It updates two rates based on that feedback message. If I just take one update and I apply the algorithm and I just change the rate, then only one rate is being changed, not both rates are being changed, because the other flows are waiting for their feedback message. So I have to basically emulate the behavior as if they would have gotten the feedback. That's another specific thing. It's not hard to do. It's a small change. But just like that, you have to take a look at the algorithm and see, okay, I cannot just change a rate or a value and then, for instance, TFRC. TFRC does some calculations on the receiver side. If we simply change the sender side, that's what we did. It works so-so. can work much better if you change the receiver too. But if the receiver makes assumptions about the rate and you change the sender to have a different rate and you just ignore what the receiver is doing, won't really work, right?
Okay.
So for every algorithm, you have to use a little bit of logic to show what assumptions are there that we might be breaking, but just enforcing a different rate. We're just taking the rate and changing it. And if your algorithm makes an assumption that the rate is something else, then things may go wrong, right? You cannot just blindly apply it without doing anything to it.
Michael, is that something?
And we're making this as easy as possible, right? So that's.
But is that something that can be clarified in the draft, perhaps?
Yeah, that's what I'm saying. We're putting recommendations, and we're trying to be as generic and clear as possible by what we learn from applying it to these different algorithms to say exactly what I just said. Like, for instance, if there is an implicit assumption about the rate being something on the receiver side, and it's just changing it on the sender blindly, that may go wrong and may need to change this. So these kinds of recommendations are going to be there.
Okay, so I think like that kind of recommendation will be good to know. But I hope like that's not really guiding my algorithm to really cope up with this kind of mechanism. And I see if that needs to be done, I see for future, I don't see really much of its use of this kind of shared bottleneck or like coupled constraint.
Let's take the presentation first.
Yeah, this is okay.
Yeah, cool. So how do you complicate it? How complicated will it be to if somebody else comes up with a new congestion control scheme and wants to apply the coupled congestion control? Do you think it's possible to do it what's in the document right now, or do you have to be a real expert and get into all the details? Like, how complicated will it be?
How complicated is it to apply this to a new congestion control mechanism?
Yeah.
Not very. If you know it a little bit, then it's about making sure that there are no assumptions in there, implicit assumptions about the rate that are broken. Things like I just said, if the receiver assumes that there is a certain rate from the sender and we just blindly enforce a certain rate, of course things go wrong. But that's something, if you understand the algorithm a little bit, then you adapt that. So it's not
algorithm,
very.
you mean the congestion control algorithm?
Yeah.
Okay. Would it be valuable to document those things or like how to apply it to NADA, for example, which you have already
No, that's
done?
exactly what I mean. That's what we're going to do. So for all the algorithms we apply it to, we're going to say, okay, to apply it to this sort of thing, we have to do this too. And also for instance, NADA and Scream, we can come up with recommendations.
Is it just recommendations?
Or like, no, how you would use it.
You
can specify how to apply it.
And just, I mean, the other possibility to proceed here would be actually to have separate documents which say this is coupled congestion control for NADA, this is coupled congestion control for Scream, or whatever.
No, because it's just a paragraph. It's a short thing. It's a simple thing. It's a simple small change, but for every algorithm you need to have a little bit of logic of how you do it.
Okay, that makes sense for me. Okay.
So Stein Jessing, as one of the authors, maybe we could try to make an interface, a generic interface between the coupled congestion control and any CC mechanisms. If we find
let's take that offline.
Okay,
I think that's the best. Yeah.
So we could work with NADA with.
Yeah, no, because of what I just said. I don't think it works as you say. But let's take that offline. That's okay. So next slide. All right, a quick recap of what we've done and what this is, right? It's a method to control multiple flows. The major goal is to be as simple as possible and at the same time achieve prioritization as required by RFC 7478, which is now the published use cases and requirements document for RTC Web. The expected side effects, but do note that these are side effects, reduced delay and loss, because basically by controlling the flows together, you can avoid a little bit of this competition between flows. Results that we had before, the things they're going to see here, is that prioritization was always achieved, and side effects was that it was doing very well with RAP, which was a rate-based AMD mechanism, and with LEDBAT, and not that impressive with TFSC because of what I just said, but also working okay-ish. So now, next slide please. Applying coupled CC to NADA. So these are some results that were derived from using the previous version of the algorithm. We tested using the new version of the algorithm, where the results are not as good as with the older ones, but we're also trying to understand what is going on. There is something with the accelerated ramp-up that makes a misunderstanding about what is happening here. Anyway, so with the previous version, you see that it looks a bit better. The delay seems to vary a little more, but towards lower, so that is a slightly better thing. And of course we can enforce perfect fairness. To understand better the effect of the delay here, I made a CDF. That's on the next slide. So Shafiqul did. So here's a CDF over the delay values that you see in the plot below, which seem to be a bit favorable. So that's a good thing. Also note that the better a mechanism works at keeping delay low, and when there are multiple flows, the smaller the impact in terms of delay gain of using the couple congestion control will be, because it's reducing essentially a problem that the mechanism has. If the mechanism is doing well, then there's not so much gain from applying it, right? Okay, next. That is the test. So the setup here. This is all simulations. The setup is the same that was used in NADA, I think, in slides that we have seen on one of the previous meetings. So in this case, the capacity was changed along with the number of flows. We also did tests where we didn't do that, and it looks very nice. So you see that a bit of a problem starts to happen when there are very many flows, but I think that's probably also at the limit of what is realistic with RTC web. And we're looking into it. We're trying to understand what goes on. The average queuing delay, well, it's overall a bit better. Next. Well, that's a throughput plot, so that was nice for us to see that sometimes we were getting these benefits, but at the cost of slight cost of throughput. That didn't happen with NADA. It was really on spot, so spot on. Next. Yeah, that was it. That's the update on the results we have so far. Shafiqul is working on them and improving them further. Any questions?
Mia Kuhlwind again. I'm not requiring this, I'm just asking out of curiosity, are you planning to apply this to Scream? How far did you look into it already?
Okay, so what I can say is that Shafiqul has taken a look at the code that is now made available and found it a bit complicated and hard to use. But that he told me to stay away from complaining about the code now, because he needs to look deeper before he would say that. So it's maybe not, it's preliminary. He is looking at it. Yeah.
Just good to know.
Yeah, I mean, you just said like it's complicated and all this thing, and then you also said like not really make fuss about it. So I would really like to get a feedback. What's complicated?
Yeah. So that is the plan. I mean, actually, we just had a Skype chat where we agreed that he would take a deeper look, and then if he finds issues, he's going to put that to the mailing list.
Because it seems like we actually have to show how it works with this script anyway.
Yeah.
Because you said like you have to do the changes. But on that note, I mean, is it like the functional change that you need to do in this algorithm, or is just like some parameters you have to tune?
There are things that may go wrong based on the assumptions. So in the newer version of NADA, for example, there's this accelerated ramp-up, which isn't there in the previous version. Now, the accelerated ramp-up, whenever the queue drains below I think this expected value, it quickly increases, right? Doing what we are doing, we enforce that the flows go further down than what NADA would normally be doing, so it drains even faster, which provokes this accelerated ramp-up. So maybe that needs to be tuned. I mean, it's still, even with the accelerated ramp-up, we have positive results. So it works better than not with FSE. So I mean, it basically works, right? But there can be some small things in the algorithm that, where there is an assumption that we break by enforcing this, so these things need to be looked at. I don't know about Scream. I mean, we have to just look at it.
The thing is, like, I might sound very critical about it, but I'm actually trying to say, like, I mean, all these algorithms that NADA is Scream with, they have like self-fairness kind of, and then fairness against TCP that we have been showing, right? And then you are also messing up with our assessment of that network. I think that's where I think it starts to break, and I think that's what you have been found, perhaps, that, well, as you said, like the ramp up is tough. So some special feature per algorithm actually makes it a bit hard. I mean, so I think it's going back to what you're saying, like perhaps it's knowing each other a bit better, like the way to actually Scream or the Rmcat algorithm knows that there is something that can handle the fairness. I don't need to enforce it or something like that. Like those kind of things, I think, need to be discussed before to see how we proceed with this one. But I would like to.
Well, I mean, so far, what I can say is that it seems to work with both the old and the new version of NADA. It does work. Yeah. Even if you just ignore that accelerated ramp-up thing, it does work and it does yield better results.
Okay.
So.
So, I mean, I totally understand you that you can't prove that it works for every algorithm, right? That's impossible, and it shows really good results. So I'm convinced it works pretty well for whatever we specify here. But I would feel a little bit better if I would see that it works at least for 2 Rmcat.
Yeah, but there are only two that
yeah,
are repeatedly being.
Just my personal opinion. And then the other thing is, if you really want to make sure that you don't describe something which might break in some case, it's really the other possibility is to specify coupled congestion control for a specific scheme, for NADA, for example, and then just add text how you could use the same, give recommendations how you could use the same kind of scheme and apply it to a different congestion control.
As I said, applying it, for instance, to NADA, like the things that you would need to do to NADA, that can be written in one paragraph.
I'm just
or
saying
like
the
the same
approach
for all
would
the
be different.
mechanisms so far.
Instead of trying to specify in a document a very general mechanism, you could specify a very concrete algorithm which works very well together with a very specific congestion control, and then have an additional section which actually explains how to apply the same mechanism to other congestion control schemes.
I agree in theory, but the mechanism seems to just work very well without requiring a lot of changes on a broad set of algorithms already. So I don't think it's necessary. I see the idea, but I don't think it's necessary. I think it works well enough for that.
The point is you say it's a theme, and I don't think, and so on, and
Yeah.
I don't understand.
Okay, yeah, that's because I'm academic and I'm cautious.
I do believe you
It does work very well with a lot of algorithms already.
Yeah, but it's,
So
I mean, it's really hard to actually specify something, write it in stone. As you said, it's hard to do something generic. So why should we actually go into this case?
Well, because that is a mechanism that works with a minimal set of changes to these algorithms, and like I said, it already does work well. It's not like it doesn't work. It's a very small thing you need to change, then you do that, and it works. It's like
I understand. I don't think that specifying is for a certain mechanism and then give a recommendation how to use the same thing for other thing would stop people from using it. I think it would be the same thing. It would just be on the same safe side for what we specify. But that's my personal opinion. That's it.
So maybe it's just to clarify, maybe I don't quite get what you're asking for. You're asking to have a different mechanism, like different mechanisms.
No, I'm asking to have one document which says basically in the title coupled congestion control for NADA, or based on an example for NADA, or whatever you pick. And then you can be sure that it really works well with this document. You can address all the concerns with the fast ramp-up and whatever, and then just have a section or like the second part of the document which explains how to apply the same algorithm to different congestion controls and give a recommendation on it.
Okay, but like I said, the length of, the thing is that applying it to NADA, probably also with the newer version, but maybe 2 paragraphs, right? So that's why
it doesn't change. It doesn't
right,
change.
it doesn't really change
a
the
lot.
content.
It doesn't change the content. That's the important part. But it's a different thing if we try to. I think people will be more concerned if we try to standardize something very general instead of standardizing with something concrete where we know it works.
I see. Okay.
David Hayes, University of Oslo. I think one of the issues here is that NADA and Scream have both been designed without any thought of a coupled congestion controller working with them. Okay, so now we're integrating that in. Coupled congestion controller can control more flows than just the NADA flows and enforce the priority that Rmcat needs with the video and other traffic. So that's important. But once this has been standardized and put in, any new congestion control algorithms will be designed with coupled congestion control from the start. So you won't have the same sort of problems that you're having now. So they'll be designed to use the coupled congestion control that has been standardized. So it's a different issue that I don't believe should happen in the future because we will have that to work with.
Varun Singh. So a couple of points. I just want to make sure that we don't set the bar too high for like for generic mechanisms such as this and even FEC, that it has to be applied, it has to be shown to be applicable to various forms, because I think if you have 3 or 4 mechanisms, it takes a lot of effort to get there. On the other hand, I would also like to point out that if couple congestion control thinks, so going back to what Stein and what David said, that if you think that there is something that as a requirement from the congestion control, that you think that the couple congestion control, like please do this, like the congestion control that it works on top of, you make some requirements towards them so that they can modify their algorithm so that you don't have 4 variables suddenly that you have to...
That was plain text for the next version, absolutely. Yeah.
Right, and that would actually enforce people like
we have to close the line now.
Producing new algorithms, both NADA and Scream, to take that into account and maybe make changes on their end so that they make your life easier, right? So, on one hand. The third point was that there are, I believe, both GCC and Scream make some remarks towards multi-flow or how to control their multiple flows. So, I don't know if these documents are actually on conflict with the couple congestion control. So, as in, these are my 3 points, and like these are 3 remarks which perhaps don't help your cause in all the ways, but...
Okay, I can answer the Scream multi-flow thing. So the you can, like for any mechanism, you can always do better by having one single congestion controller and just scheduling among the input that you get. So that is mentioned as a possibility. It has disadvantages and advantages. It's for only one mechanism, if that is what you're having, if you're not, for instance, combining multiple different mechanisms, which we're also going to look at in the next version, then this is the best thing you can do. It's probably not very easy implementation-wise to turn on and off coupling. If, for instance, you get a shared bottleneck detection feedback and you know that dynamically you want to turn this on or off when you're just scheduling out of a buffer. It's an implementation decision. You can do this or that. This scheduling thing is very briefly discussed in the couple congestion control draft, because that is, it's an easy thing to say, and depends on what you want to do. You can do this or that, but for evaluation, there is not much to evaluate about this scheduling, because there is just one congestion control mechanism which just works as it does. And so all the evaluations here are about the other mechanism that is able to dynamically turn on and off the coupling for cases when you want that.
Okay.
Yeah, if it is, if this could be solved easily by a scheduler, a simple scheduler, then why would I have an mechanism that need to be tuned, or more than analyzing the algorithms to be tuned in place? That's one thing.
I just explained that.
Yeah, you explained it, but I don't see that's actually helping it.
Yeah,
but I also disagree with Hayes, say okay, I don't want something to detect how I design my algorithm from the very beginning, right? I would like to try out different things and try to see how it's working better. The point is we have TFRC algorithm, we have some other algorithm that Michael has used in this there, and then basically we said that's not good enough. Rmcat needs new algorithm. And at that time, we also, in the requirements, we also said it need to be worked with something that if there is some shared bottleneck detection or something, or couple congestion control, it should work with. So we have this built in our algorithm. What I'm saying, if we take out these things from Scream, GCC, or NADA, even NADA could do this scheduling there. It's not there, but I don't see any point of not integrating. If you take it out and makes one single block saying this is how my couple congestion done, and a scheduler or whatever, then perhaps it will work better. And then it needs to be more generic. I'm just afraid that if you don't show the results of this scheme, I don't know how to do it. And if somebody else come tomorrow with another algorithm, you need to again change. And that's why I agree with Maria. Maybe it's more valuable to have those kind of sections saying okay, this is my general algorithm, this is how you tune with working with NADA, and this is how with this schema, this is how with something else.
I said a number of times already that these sections will be there, so I don't exactly see what you're asking for.
Kulevin again, I want to reply to David's comment as well. So I think that, and that's a very general comment I make, I think I personally think it's more important that we have what we do here well specified so it can be used out of the box without figuring out all the details. And not designing something which can be used for future congestion control, which might or might not appear, because if we end up in this working group that we specify something which will not be used by WebRTC, then we failed. So if we have something that can be easily applied and it's very well specified, that should be favored in my point of view than something very general which might or might not be used in future.
I completely agree. I would also like to say that what I said about requiring evaluation of Scream was about adopting as a working group item, not about the final version. So I am envisioning a document where we would clearly specify this is how this works. I mean, code, that is how you do it with NADA, that is how you do it with Scream, when these are stable. That was my request. But
as a chair, do you want to ask for adoption, or I don't think that you do?
I'd like to,
okay.
if you want.
We can.
So you want to have I mean, we closed the line. Is it very important?
It's not a request, but I think it's important to bring out that looks like we need a discussion to talk about the 3 different ways of handling multiple coupling flows. That was the main kind of point of debate. Not now, but maybe on the mailing list. The one where you have a single congestion control, you schedule, which gives you perfect result. The one where you have coupled congestion, and the one where, for instance, in NADA, you could handle priority sort of without the help of a congestion control, sort of without the help of a coupling layer, right? So I see that discussion being missing, but it can.
Let's talk offline.
Yeah, and it could, perhaps if you take that offline discussion, you could also evaluate whether that could be a discussion that could be appropriate even for the draft. Such a discussion could even possibly be something that could go into the draft. At least please consider that.
Like I said, the scheduling is already there. So it already says this sort of.
So, definitely, I think it's very early to have more discussion on this on the mailing list. We started discussion here. Please go on the mailing list. I don't think there's any rush for adoption, right? I see there's interest in the working group. You keep on working on it. That's good work, and we just keep it at this state right now. Thank you very much.
So basically, this was the Rmcat session. I will hope to see you in Prague.
Yeah, right now.
No, I have to get into the stuff, but it's getting not clear. We get the minutes from Bayern, then perhaps one of us will look at it to make sure.